So we always get the question at the beginning of the semester, what are the labs going to look like in technical physics? So let's take a look at how we navigate to the labs and what they're going to look like. So generally, your page is going to look something like this, and I like using the modules to navigate, so we're going to click on modules, and when we do so, we should go to the modules page. I'm going to go to the first lab. I'm going to skip the two tutorial labs for right now. The first lab is the lab module 1, and what we're going to do is we're going to look at how the first lab set up. All the labs are going to be generally the same. I will give you the data, you will calculate the output, the results, and you will report them in the lab. Because the Canvas environment doesn't really have a lab format, I'm improvising and using the quiz format, and you will become very familiar with that. So let's go ahead and click on that link, and you can see here we have lab exercise 1, accuracy of measurements. Sorry, it's truncated a little bit and cut off. But what you're going to do is, after looking at this background information, okay, this is purely background information above here, you're going to see at the bottom, complete the lab report in Canvas. So we're going to click on complete the lab report in Canvas, and I'm going to do a quick preview. You can see here you're going to again have a look at the background information for the lab. But when I click on preview here, for me, because this is my environment, not your environment, you're going to start seeing what are listed as question 1, question 2, question 3, 4, 5, 6, 7, 8, 9, 10, as many questions as it takes. That is your lab. That is the format. So if we take a look at these one at a time, question 1 will always be write the abstract. Please read the information in here on writing the abstract. The abstract is, although it's the first question, it's the last thing that you write. An abstract is a outline or a intro to everything that you did for the lab. So although you're going to do all of the information first, save question 1 for the last entry you make and write the abstract. The abstract's the last thing you write. It includes an introduction to the lab and some particulars associated with the lab and summarizes your findings. Please note, it should be 4 to 5 sentences in length. It does not have to be very long. It should be brief, but contain the results. The results means you give me back the information that identifies the results for this lab. Okay, the results will usually be something along the lines of percentage of error or difference. If you don't give me a results statement in here, you're not going to get credit for this question. So don't give me a bunch of background, don't give me a bunch of calculations. Give me the results in there and what you felt about those results. Question number 2 is the theory question. Write the theory. Use the equation editor. Do not use the text editor. Those first 2 labs that you did teach you how to use the equation editor. Use those in this section. You'll notice here on the bottom, it looks like a mini word processor. This is how you enter the information. The text editor is this button right here, insert math equation. So when you click on that, it's going to create an environment here for the equation editor, just like you use on those first two labs using the equation editor. The theory is derived from the statements made in the lab worksheet given to you. Okay, you will describe the tools and equipment. Okay, I'm not really too carried away with that information, but what I want you to do is use that information that derives the mathematical explanation or expressions that are basic to this lab. Be succinct, not too verbose. Pick out the correct expressions that identify the theory. Then what you're going to have here is a question in each case that asks you to calculate something. In this case, you're going to calculate the mean value. You will notice I have given you the values, in this case in centimeters, centimeters, and grams. I expect to see the results in those appropriate units associated with your answer. So in this case, the mean value of these three will go here. The mean value of these three will go here. The mean value of these three will go here. The mean value of these three will go here. If you do not include the units, then it's just a number. You get it wrong. So question 3, in this case for lab 1, asks you to calculate the mean value. Question 4, calculate the mean value. Question 5, calculate the mean value. Question 6 then asks you to calculate the volume and density. Where do you get the volume and density? You're going to calculate it from the first 3 questions. So in this case, the volume of the wooden block, question, length times width times height, you're going to put the information in here, and you are going to put the correct units associated. Question 7, calculate the volume and density for the aluminum cylinder. Again, the value and the correct units go into this block. Question 8, calculate the volume and density of the steel sphere. In this case, you're going to put the value and the units associated. They will not always be the same. Notice back up here on question 5 for the sphere, now we're in millimeters and grams. You have to be able to identify what the best units are when you're doing these. This is part of your results calculation, calculating the percentage of error. So in this case, the expression that defines the percentage of error is the absolute value. That's what those 2 lines mean on either side of the expression in the numerator. Theoretical value, experimental value. That value that you find associated with theoretical value of wood, oh look, it's right here. And then your value. The absolute value will have no positive or negative associated with it. You divide it by the theoretical value, you multiply it times 100, and what you end up with is your percentage of error. So you're going to have a percentage of error for the wood block, you're going to have a percentage of error for the aluminum cylinder, you're going to have a percentage of error for the steel sphere. Finally then, what I want you to do is wrap it up. In the wrap-up, this is your discussion. Again, it's a restatement of the results of the lab, usually the percentage of error and difference. Please read what I've put in here that guides you through the lab. Use complete sentences, grammar counts, end on a note of finality. Do not start your discussion with "in conclusion." Okay, so in every case here, you're going to enter the information into this field, and then when you have it all done, you are going to submit. Sometimes when you submit, because the internet is what the internet is, you might get an error. Hopefully you have saved this information somewhere else so that if you have to start over again, you can do so. Do not ever send me your results as an email or some other format. If you don't submit it in Canvas in this format, you're not going to get credit for it. And if you tell me you do, I'm going to kick it back to you and tell you, please resubmit in Canvas in the proper format. So this is the way that the lab will look for every lab throughout the EGG 131 lab section. I hope that helps. Good luck on your labs. If you have questions, please let me know. Thank you.